To our panelists, we have two. Dr. Steve Crocker, who is truly a founding father. I don't know where you Hamilton, Madison. I don't know if you thought that one through. He wrote the initial protocols for an early version of the Internet in 1969. He now chairs the Internet Security and Stability Advisory Committee for ICANN. He's also a liaison to the ICANN Board of Directors and currently CEO of Shinkuro, a collaboration technology Internet infrastructure security firm. We also have Paul Hoffman, the first background in the business side of the Internet, hosting, marketing, and e-commerce, coming from UUNet, which really was, as a corporate matter, one of the fathers of the Internet, making all this happen. And he's Vice President of Hosting Services after that at Epic Internet, and is currently President of Pounce Consulting, which is a great Internet age name for a consulting firm providing technology and software development services. We're really lucky to have these guys here. We've got some drinks in the back, and without further ado, Dr. Crocker, I think we're going to turn to you first, but again, thanks for joining us and thanks to our sponsor.
When we built the original network, we were thinking in terms of one computer talking to another, about one user being able to remotely log in and type at another computer as if they were there. Email rapidly became the dominant application, and then much later from our perspective in the 90s, this thing called the World Wide Web came along, and all of a sudden that became the dominant application, and it may be, from a certain perspective, the only thing that most users even think about in terms of network. That, from our perspective, is just another application, voice over IP, Skype, and so forth. We've got another YouTube and the like. All of these are layers and layers of new technologies that span greatly. So belaboring this a bit, the importance of keeping things open so that new things can happen. And as part of that, keeping the governance mechanisms as lightweight as possible so that the technology can move ahead. Here's the ARPANET was built in 68, 69. First node was put in September 69, and then roughly a month after that for a period of time. Built as a research project, as I mentioned, and a fair amount of organization to the basic process of moving bits and packets around, and very little organization into what to do with this network. And that was left to kind of self-organize. And as I said, I was UCLA. It was left to graduate students, and sort of in this environment, it'd be like leaving it to staffers to figure out, because it's not important enough for the principals to sort out. And so we started to figure out what we're going to do with this network and design the original set of protocols. Here's the very carefully drawn map of the first 4 sites, UCLA, Santa Barbara, SRI, and the University of Utah, with the computers that were connected to them. A few months later, expanded to the East Coast, and then here's a decade later where the nature of the graphs starts to change rather dramatically as it grows.
To start with, I wanted to give you a definition. It's about what the Internet is. You've heard Steve talk about a lot of different things, but I think it's important to understand what is the Internet. And as you can read here, this is Webster's, Hoffman, whatever. I mean, you can get any of it. It's an interconnected system of networks that connects computers around the world via TCP/IP. So now everybody understands the Internet and know what it means. Everything's good, and we can all go home and tell everybody about what the Internet means. But it's a basic definition, but also it's an important definition, because really that's the fundamental of what the Internet is. The Internet is a collection of networks that are working together. And TCP/IP, you may have seen that before. If you're clicking around a computer and you click on your network settings, you'll see the term TCP/IP. So that means 2 different things. It means transmission control protocol and Internet protocol. And the way I like people to think about this is think about when you want to send a package. Okay, I want to send something to my grandmother that's in New York. On TCP. And what I'm going to do is I'm going to decide what that package is, what's going to be in that package, and I'm going to put an address on that package. And then the IP part is the actual address. And that's going to tell the postman, how do I get that package to where it needs to go? So that's what's happening on the Internet. Every time you do something, whether you do an email, the web, or whatever, every bit of information that you're typing into the computer, when you hit the enter key, it's broken up into packets, gets addressed, and then it goes to its destination. And to give you a real simple example, we're going to make a little Internet to show you what that looks like. You're going to try again? Why don't you be the input? Okay, I'll be the input. Okay. you two stand over there, and I'll stand over here. These are packets, okay? No, they're not balls, they're packets. And what we're going to do, come over here, is we're going to make a little network. She's going to be the starting point for where the information is going to start, so she's going to have all the packets. Okay? Now we are going to be nodes on the network, and that's what a network is made of. The network is made up of nodes that can be called hops, hubs, whatever you want to call them, and there's fiber between them that connects us. Now what she does as an internet point, she takes those packets and she needs to decide, okay, if I want to go to Larry, what's the best way for me to get there? So she looks at the network and she goes, okay, I can go that way or I can go this way. Which is the best? She goes to me, because then I go to Larry. And now we've gone 2 hops and he's got the end message, or the blue ball, depending on your perspective. Now, we get in a fight. She doesn't want to talk to me anymore. But she still wants to get her message across. So now she needs to find another way to get the ball there. Okay, so she's not talking to me anymore. So now she went the other way. That, in a nutshell, is how the internet works. I know it seems overly simple, but what the internet does is an amazing little thing. Is the internet is a collection of all these interconnections and all these little nodes. That's fine. And what happened, what was designed for, was originally designed for withstanding lots of things going down. If there was a war or a bomb or something like that, and a bunch of things went away, but the traffic could still go through. So it's a network that allows traffic to find whatever the best route available is at the time to get where it wants to go. And that makes it very reliable and makes it work very well. So now think about what we just did on a much grander scale. We've got thousands and thousands and thousands of network providers out there, all interconnected, all exchanging these little balls around to each other and passing information all over the world. So, you've got all these networks. Who has these networks? Well, a lot of them are owned by telecommunication companies now. There used to be a lot of what were called ISPs, Internet Service Providers, but most of those are now owned by telecommunication companies. They provide a lot of the infrastructure for the internet. A lot of universities still have networks they run and connect to each other, and a lot of traffic runs over those. Governments, both here and in other countries, have networks they run that connect to the internet. Large companies have networks. GE, IBM, all these companies have networks that are global in span that also connect to the internet. And Steve talked about this, all these organizations. Nobody directly owns the internet, but lots of bodies oversee it and make sure things are running well and provide standards and ways for the people to work together on the internet. Okay, so this is an example I wanted to talk about when I talked about the growth of bandwidth. Back in the very early days of the internet, we had bandwidth that was, the terminology then of a backbone was about 1 to 3 megabits. This is today's standard, a very small number, but at the time it was a very big backbone. But all we were doing was very basic things. Email, FTP, what was called news, which is basically just feeds of information. It's all very data-driven traffic. It's not very large. But as things changed, as time went by, the web got bigger, more and more things were happening on the internet, traffic got larger. Now you start seeing audio and video commerce, traffic got even larger. And eventually you're going to start seeing MRIs transmitted over the internet. You're going to see phones. You're going to see your appliances get on the internet.
I don't see any. I'm Larry Irvin, for those who got here late. I'm co-chair with Bruce Melman, and Laura Spinning is our executive director. I think on behalf of all of us, I want to thank Paul and Steve for joining us and for this. Our purpose today is really straightforward. How to give you a sense of, some of us actually lived through the 90s and lived through the net. And I actually remember when there wasn't an internet, was involved in a lot of these things. But for folks who the net always was, and it just is, I want to give you a sense of what happened, how we got to where we are, because a lot of important policy decisions weren't made in the government. They were made by men and women like the gentleman here, entrepreneurs, innovators, scientists, who just made smart choices that enabled all of us to benefit from the way. This is the first in a series of IIA Academy seminars. We're going to periodically bring it together. There's no policy discussion really. It's to make us smarter, make you smarter, hopefully help your bosses get smarter about what technology is, where it's going, why you should care, and how we get to a place where the next generation of users of the internet have the same kind of benefits we have. So with that, we promise to get you out of here by 1:30. We're on time and on budget, so thank you very much for your time today. If you have any questions, please feel free to contact us. Take the broadband fact book, and this is the static version of the broadband fact book. We will have a dynamic version of this on the web. It will constantly be updated, so more information on what's happening with regard to the internet, what's happening with regard to broadband, will be available at internetinnovation.org. Thanks for your time today.